Welcome back to another video in this mini-series. I'm Brad from Geon Technologies. In the previous video, we readied our EKS cluster and partially configured our Redhawk system to start talking to it. In this video, we're going to bring everything together. We're going to install the Redhawk cluster plugins for EKS. We'll configure the cluster configuration file to use that selected plugin. We'll configure Core Framework's access to use the AWS and Kube control tools. And finally, we'll adjust the components spd.xml files to make them usable by the EKS plugin. At the time of this recording, there aren't any RPMs readily available with the Redhawk containerization capabilities, so I'm going to be showing how to install the plugins from source. I have already built and installed Core Framework from source, and within the source tree, I'm going to navigate to a total of 3 different locations. One location to install the Sandbox EKS plugin, another location to install the Application Factory EKS plugin, and one final other location to set up the cluster config file. We're going to follow the markdown documentation to guide us through this process. First, we'll install the Application Factory plugin. So that we can verify that the install process worked, we'll first show that there is no plugin installed, then check after the installation process to ensure the plugin got installed where we expect. Application Factory's plugin shared object files are installed to ausihome/lib. The installed files all start with libausy cluster. As we can see, there is no Application Factory plugin in this directory because there is no shared object files here by that name. We'll navigate to the correct location in the source tree, then run the documented commands to install the plugin. After installing the plugin, if we rerun the ls command, we'll see that the shared object files are now present. So the Application Factory plugin is installed. Let's move on to Sandbox. Sandbox installs its Python files to ausihome/lib/python/aussie/utils/sandbox. There are 2 files of concern. The first, copied into this directory by the make file, is the actual Sandbox plugin itself, which is named pluginname.py. So for our EKS Kube plugin, the file name is ekskube.py. As we can see, that file is not present in this directory, so the Sandbox plugin has not yet been installed. The other file is called cluster.py. Cluster.py gets rendered by a Jinja template at install time to point to the actual plugin Python file. First of all, we can see that our ekskube.py is now present. Secondly, if we look at cluster.py, we can see that it is importing our ekskube Python file and using it. So we're now confident that both Application Factory and Sandbox ekskube plugins have been installed. Now that our plugins are installed, we need to set up the cluster config file. We'll continue to follow the official documentation for this step. We can install the cluster config file and pass arguments to the make file to have it set our desired values in the file for us. The corresponding values in the configuration file are documented on the plugin's markdown file. We're only really concerned with the registry value in this video, but we'll pass a Docker config JSON value as well for demonstration purposes. We're only interested in using Redhawk component Docker images readily available on Docker Hub, so we're going to set our registry value to Geon Tech to use those images. The tag variable will be set to latest by default, so we're good there. Finally, because the images we intend to use are available on Docker Hub, no authentication is needed to pull down those Docker images onto the EKS cluster, so the Docker config JSON value we're passing into the config file isn't actually being used, it's just for show in this case. If our images were hosted on a private container image registry, we would set the registry value to reflect that private registry address. Then we would make sure that the Docker config JSON variable got set to a valid base64 encoded credential set. Those creds would get converted into a Kubernetes secret by the EKS plugin, which would allow the images to be successfully pulled from the private registry. Just so that you can see that I have nothing up my sleeve, if we look at my home's .docker/config.json file, we'll see an example JSON that is syntactically valid. This particular auth field is a long-expired temporary credential used for AWS ECR, which is why it's safe for me to show you this file. By default, when you perform a Docker logging command to log into your private image registry, your username and password are base64 encoded into this file, which is why Redhawk will attempt to use this file as a source to create its secret object. These particulars are also documented in the plugin's markdown file. Let's open up the cluster config file and take a look at it. It has our registry value set, along with a valid Docker config JSON value, albeit one that won't be used to perform any pool operations. The Kubernetes secret object will still be created, but it just won't be used. So now that our cluster config file is all set up, we need to make sure that Core Framework can properly invoke the AWS and kubectl binaries. We previously configured our AWS binary and kubectl binary to communicate with our cluster as the Redhawk IAM user, so what's left to do? Redhawk expects to find the AWS and kubectl configuration files in very specific places. If we look at ausihome/etc/profile.d/redhawk.sh, we can see that when this script is sourced, which you would typically do before running waveforms, several AWS environment variables and one kubeconfig environment variable are set. It's these variables that tell Redhawk where to find the AWS configuration files and the kubeconfig file. When Redhawk is installed, it creates some fake files in ausihome along with readmes that instruct you to set up these files properly, and that's what we're going to do. The first two files are in ausihome/AWS, and the third is in ausihome/.kube. .kube will hold our kubeconfig file, and the AWS subdirectory underneath ausihome will hold our AWS binary configuration files. Because we set up our kubeconfig file already, we can just copy and paste it into this directory. So we'll go ahead and do that, and then just confirm that the file is there as expected. And it's there, and that looks good. As for the AWS files, let's take a glance at the README. It says to set the appropriate values in the config and credentials files, and then remove the .fake suffix from these files. I've already done this, so to show you what those files ultimately look like, in the config file, we specified the AWS region where our cluster resides, and in the credentials file, we set the AWS access key and secret access key for our Redhawk IAM user that was in the CSV file that we downloaded in the previous video. And that's it. Redhawk will be able to use the AWS and kubectl tools so long as the environment variables are set properly to point to these configuration files. All that's left to do now is ensure that the components we want to use in our waveform are properly configured to be ran by the EKS plugin. We want to run a waveform called test all types that runs 4 different Redhawk components. These include data converter, which is running inside of a component host. The waveform also includes hard limit, a component included with Redhawk by default, as well as a GNU radio component called double ref, and a custom Redhawk component called gain. We're going to make sure all of these components are set up to be ran by the EKS Cube plugin. The EKS Cube plugin will parse the component's spd.xml files and look for special values. First, the code type's value must be set to container to signify that the installed container orchestration plugin is to be used to run this component. Next, the entry point is extended with a double colon delimiter followed by the image name. As you can see, the image name is not complete. It is not fully qualified with the registry to find the image at, and it doesn't have a tag specified either. This is because the registry and tag values are specified in the cluster config file we looked at previously. Redhawk will concatenate the cluster config's registry value with the component's image name, and then finally append the cluster config's tag value to create a fully qualified image name. Because the registry and tag are specified in the cluster config file, this means that all of your images must be in the same registry and must share an identical tag. So we can see that this component is ready to go. Let's quickly check on the others. I will call out data converter and component host in specific. Data converter is a shared library type component, so it's meant to run on a component host. We leave the spd.xml alone for the shared library type components. What we want is to make sure that the spd.xml for component host is set to the container code type and has its entry point set correctly. Your component host image used should have your desired shared library components baked into the image. The component host image provided on Docker Hub includes data converter, source SDDS, fftlib, and DSP by default. The Docker Redhawk components repo on GitHub includes assets and documentation that you can use to create your own Redhawk component images, including a customized component host image. So all of our components we intend to run in our waveform are properly configured. We're finally ready to run our waveforms. We're going to run our OmniOrb and Domain Manager on our local Redhawk system, and when we launch our waveform, it will register with these Redhawk services. Let's make sure that they're ready to go. We'll reset OmniOrb and make sure that Omni Events and Omni Names servers are running as expected. And in the terminal where Domain Manager will run, we're going to source that redhawk.sh script we saw from earlier to properly set our environment variables. We can see that our AWS environment variables are pointing to the correct places, our kube config variable is pointing to the correct place, and that our LD library path includes ausihome/lib, which is where the Application Factory plugin is located. If your LD library path does not include ausihome/lib, Domain Manager will complain about being unable to locate your cluster plugin, and your waveform won't launch. Let's use kubecontrol to verify that there are no Redhawk associated pods or namespaces on our cluster. We don't see any namespaces or pods associated with Redhawk created yet, so we're confident that we're starting from a clean slate. Now we can open a Python terminal and launch our waveform. We're going to run this test all types script and walk through it chunk by chunk. First, we'll import the Redhawk and Sandbox libraries. Then we'll connect to our started Domain Manager. We'll create a SIGGEN component in the Sandbox. And if we check on our cluster, we'll see that the Redhawk Sandbox namespace has been created for our SIGGEN component and that it's running inside of that namespace. Next, we'll run our test all types waveform. Waveforms are launched into uniquely named namespaces to prevent namespace collisions on the cluster. If we check our cluster for pods now, we'll see the additional component pods running in a namespace with waveform in its name. The default create application timeout value of 60 seconds still stands. If your component images are many and large, and are being pulled over the internet onto your cluster, and those Docker pull operations take more than 60 seconds, the create application call will time out. If this happens, wait a minute or two for your images to finish being pulled, and then rerun create application. The rest of the script is fairly standard. It will create some sinks to catch data flowing through the waveform, connect things together, then start the SIGGEN component in the Sandbox and the waveform. After sleeping for 10 seconds, the amount of data captured in the sinks is measured to affirm that data is flowing as expected. The SIGGEN component and waveform are then released. Under the hood, the EKSCube plugin is generating a Kubernetes YAML file and applying it to the cluster at create application time, and deleting it from the cluster at release object time. Because an entire waveform is represented as a single YAML file, when the waveform is released, Kubernetes will terminate all the waveform resources at the same time, but it will not return to the caller until termination of those resources completes. We can see that data was captured in our sinks, so we know that the waveform ran as expected. And if we wait just a minute, the release object calls will complete, and our cluster will be back to its clean state. And with that, this concludes this video series on using Redhawk's new container orchestration capabilities. We explored building our own EKS cluster on AWS, and configuring Redhawk to use it to launch our waveforms from both Sandbox and Application Factory. As a final parting note, everything demonstrated in this video is documented for your reference. I hope you found this series informative and inspires you to take advantage of these capabilities. For questions and comments, please contact us at geontech.com. Thank you for watching.